So this is about if register. Yes.
Doktor, kalau tak silap, counter belum habis.
Semalam eh?
Semalam dah ada kelas je.
Aduh, itu section lain lah tu. Aduh. Okay, let me open. But 8B, right?
Ya, Act B.
Okay. So I need to do extra classes later on, and I will also record. For extra classes, I don't want you to, because sometimes students like to complain. So if you think that you don't want, you said, why Dr. this do extra classes, why that, and so on. If you think you don't want to attend the extra classes, it's okay for you because it's not compulsory. But for those who want to learn, you can join. Okay, until where? Here, Cascade.
I think it's slide 37.
It's okay. I'm going to do some recap first. Then we proceed. Wait, Okay. First tarik dulu. Okay. Okay. Yesterday we already looked into new subtopic which is under Cascade counter. So there is a recap related to give me one minute. 1 minute. I need to forward this. Done. Okay, yesterday we looked into new subtopic which is under Cascade counter. This is new, but it is not too difficult as long as you know the basic last time about the modulus counter. You can see on the Cascade part it's going to combine. I can say it's combined in terms of Cascade view. You can see here Cascade view. Cascade view here. You have, let's say, you need to have 32 or modulus 32. You can combine any of two modulus. Like this example, you have modulus 4 with Cascade with your modulus 8. So when you times this together, 4 multiplied with 8, you're going to get 32. So at this certain part, you will divide the frequency following how many module, how about your module counter there. Okay, you can see here, this is first modulus 4. Over here, it will be like CLK divided with 4. Of course, your clock will be hertz. Hertz is your frequency. Okay, so your CLK here will be divided with 4. Let's say I assume we assume it's to be 10. Tak payahlah, it's going to be 8 hexa, 8 hertz. So here will be 8 divided with 4. Then you get 2. So this value will be bring here, 2 will be divided with 8, let's say. But in terms of overall, you're going to see CLK divided with 4. And then over here is going to be similar because this one is similar from here, not taking from the answer. So it will be divided with 32 all together. This is the final one. But if you want to go for one state, another one is another one state. So 2 divided with your 8 here, basically is similar, you can see in terms of the mathematical. This is 32, and there is two example here, modulus 100 and also modulus 1000 counter, you can see. So how in terms of the combinations of the cascade modulus you're going to have. You're going to have counter 1 and counter 2. And you need to remember that inside your counter, you can see here, because this is the basic one, the clock will be connected and will be from the output, whether it is from here or whether it is from here, right? As long as it is connected to the output of the previous flip-flop. Similar also, when you cascade with another modulus counter, this clock is not bringing to here, but instead the final output will be connected to the next clocks. That's why this clock will be continuous divided. Okay, so this is the basic that you need to remember. So here you can see this is the first value you have. Let's say you have 100 hertz. You have 100 hertz. Here you will divide 100 with 10. You're going to get 10. Okay, then 10 here, you can divide 10, divide to 10, you're going to get 1. But instead, you can directly bring this clock 100 per 100. Then you get 1 also, right? So that is in terms of this one. I forward salah ke tadi? Aduh. Then over here, you can see if let's say you want to develop modulus 100 here, you can come out with the cascade 10/10, but maybe you can come out with the rest others also. Over here, this is 100. We use the 10 and then another 10. So from here, using to cascade decade counter, this counter can be viewed as a frequency divider because you're going to divide all the frequency. Wait, why this one modulus 10 counter cascade 1, this connected to here, but this counter, okay, this another TC. Okay, this is this clock over here, you can see. This is only the clock for you to trigger the output. But in terms of the value of this clock is divided over here under the connections of your inputs. So it's slightly different over here, you can see. But in terms of the connection, the modulus 1000 also are having the similar. You're going to connect TC over there. 3 cascade decade counter. So you're going to be a frequency divider, the main objective of this cascade counter. And then there is example here. Yesterday we have take a look at about a 4-bit synchronized binary counter. There is a IC that you can always depend. Yesterday I asked you to remember. It's better for you to remember. If you want to like refer back to the notes later on, it's okay. But for me, it's better for you to remember pin number 1, where it's going to connect. Pin number 9, where it's going to connect, and etc. In terms of the input, pin 3, 4, 5, 6. So it's good for you to remember. And for these 4-bit synchronized, how basically it look like in terms of the connections and about the output input. You can see here from LSB to MSB. This is data input, and about the output here. So it's going to follow the sequence, similar sequence. And this is basically the similar thing, but this is in terms of dalam ni, it is inside here. What will be happen if you have the cascade counter in terms of transcaded sequence? If you have this type, yesterday I mentioned, if you have this type, you're going to have 1, 2, 3, 4. You can see this, you're going to combine it together. 1, 2, 3, 4. 4 you combine, and how many stages that are available? So for one state, you're going to have over here, it's didn't put the one stage. But if you have 16 to the power of 1, it's going to be one state, 16. But now we have 4. 4, what is the name? 74HC163. So that you have 4, you're going to have the maximum stages is 65536. So if you need a modulus of 40,000 counter only, how are you going to get? So this one, you will deduct with the full. From deduction this, so this will be your input data. But this one, in terms of your decimal, and you need to convert this to hexadecimal. See, last time, although you need to know only in terms of module 7 and a word, but this is numbering system. If you already forgot about numbering system, it's going to be hard for you later on. So please make sure you still remember about the numbering system also. After you get this value, you're going to convert into the hexadecimal, right? For the hexadecimal, this will be your MSB. This will be your LSB. So you bring this LSB to first LSB. And then C will be bring here. 3 will be bring here. And another one is 6 will be here. Your MSB. So for your MSB, okay, finish already this part. Then you have here the value already in terms of hexadecimal. But in terms of the connection, when you can see here, you have to use bit by bit. Hexadecimal got 4 bits altogether. You have hexa to binary. Hexa to binary. Hexa to binary, hexa to binary. We have C. How C look like? So you have 1, 1, 0, 0. You have 3, 0, 0, 1, 1. This is in terms of conversions of numbering system. So sometimes the value will be asked in terms of like using the transcaded sequence. You were given with this value, this figure. So it will put like maybe x here. So what is the value? Of course, it's not going to show you this one. So what is the value for the input D3, D2, D1, D0 for the third CTR DIV16 over here? Maybe you said third. So in terms of the input, okay, you need to know, okay, where is it? This will be your third one. Then it will be 0, 0, 1, 1. So this is the correct answer. Okay. Next, after you were given with all of this, you need to know in terms of analysis. I think this one is not covered yesterday. So there is a step, 4 step altogether. 4 step you need to know on analysis of sequential circuit. So from the first, second, third, fourth. Okay, what is this? First of all, you need to derive the excitation equation. See the term of excitation also, but it is not table. It is equation. So what is this? Okay, later will be example there. And next, you need to derive the next state. Last time it is still table, but now it's equation. And third one, after you have all the equation, then you will come out with table. Your next step table, similar like what you learned in your module 8A. Then you need to generate next step table, diagram, sorry. And lastly, your timing diagram. This one is, I think you are familiar with. It's not going to be hard to create the next step diagram, similar to your timing diagram. So let's take a look what is the step by step here. You can go through this step 1, step 2. You can read by yourself there, but it's better to look into the example. Okay, there is over here, first of all, let we look into the modular 4 counter. Okay, this is the look. When you were given with the look here, of course, you're going to provide with the modulus 4 counter. Okay, you're going to know what is D, what is Q, no. Okay, what is D0, what is D1, in terms of the equation. Okay, in terms of this equation, you need to come up for D0, D1. So this is for your first step. Start with the logic schematic. From the schematic, we can derive our excitation equation, not excitation table, okay? So let me proceed. Now over here, where we have this kind of circuit, our D0 now is connected to our XO. Our SO input are having Q0, Q0, and another one is CN. This is XO connection. For XO, I think it will be like this, right? Okay. So I have the input for my D0. So this is one of excitation equation that I can provide. Next, I will need it to come out for my D1. My D1 will be connected to the O gate here, and all the O gate are connected to N. So you can see it's all N here. And this N, first N, we're going to have like this plus, isn't it? So there is N first N. Let me check. Okay, in terms of the connection, it's going to be at my Q1. And another one, it will be my CNT bar. Okay, that is not here. Okay, I finished for this. Next, I'm going to have another N here. I have the input, okay, similar Q1. And then I have CNT. And lastly is my Q0 bar. Okay, it is not following the sequence, but it's okay. I just want to know, I want to share with you how come I can get the excitation equation. Okay, done that part. Another one is my last N here. First, I can see it's connected to my Q0. And then it's connected to my CNT. And lastly, for my Q1 bar. So from here, you can see this is the Boolean expression that you can come with from your schematic diagram. Okay, from your XO, you can see you still need to use the module 1 and module 3, how it's look like. So Sekarang pukul berapa? I need to forward one more things. I forgot this one. Did I forward already or not? Wait, okay. Now you can see here one step you already done just by looking at your circuit. So you can come up, might be you want to remember, but it is your luck whether this modular 4 are coming out or not. But for sure we will provide you. If we didn't give you in terms of the any hint, we're going to give you the circuit. Now the second step. Oh, kenapa you bagi jawapan terus? For the second step here, you can see you need to come up with your next step equation. Last time, if you still remember, I said D is easier. Why it is easier? Because if you remember, you have D, you have Q. This is your next Q, which is always follow the D, isn't it? Salah. It's always follow the D. You remember this table? So you can see D for the Q next is always similar to D, right? If you remember. So the next step equation is for you to come with, if you have Q0, this is your present. But for your next Q0, it will be plus. This is your next. If you still remember about the plus here, this is a present, this is the next. So now for the step 1, you already done this. But if you still remember, Q next for your D flip-flop is going to be similar to D. That's why for your Q0 plus, it will be similar to Q0 will be D0. So it will be similar to D0. So what is your D0? Your D0 is here. So you're going to come up with your Q0 plus, which means the next step equation, the next state equation. Next, still similar. If you have the D1, Q1, of course, Q1 will be similar to D1. So this will be similar to D1, which is here. So you copy paste back here, putting to the next equation. Okay, any question for this part? Okay, if no problem, we proceed to the step number 3. So construct the step table. So for construct step tables is following your step 1, step 2, step 1, step 2, and then another one, step 3 will be following your equation here. Okay, you have equation here. See, you bring at this part. Construct the next step table. This is your next step. The current one, the present, is similar to your existing input, similar to your last time. If you see, remember, you look over here, you have your CNT. Of course, you're going to have D, D1 and D0. Mana table dia? Okay, your input will be 000, 001, 010, and etc. So, how you're going to get your next Q1 and next Q0? Supposedly, it will be like this, okay? Supposedly, your next step table, next state will be Q1 plus, Q0 plus. But in terms of the summarization, it's going to be equal, right? It will be equal to D1, equal to DO, D0. So what you need to do is you need to go for here, and like this for first scenario, you have 0, 0, 0. Over here you have CNT0 bar dot Q0 is 0 dot 0, okay, plus our CNT0 dot with our Q0 bar. If you have bar, it will be toggle. So it will be 1, it will be 1. 1.0, it will be 0, plus 0.1, it will be 0. Altogether, you still get 0. So that's why here will be 0. Next, we have this scenario for D0 first, okay? For this, let me see another scenario, what will happen, how to get your next step. Now you have CNT is 0, then you have Q0 as 1 plus CNT0 multiply with Q0 bar will be 1 bar. Okay, 0 bar will be 1.1 plus 0.0. 1 plus 0, you will get 1. So here will be 1. The rest, you will always putting the value inside the equation. Then you will construct the value similar to this part. So for this part, let we see the first scenario. We have panjang 0 bar dot 0 plus 0 dot Q1 bar, 0 bar dot 0 plus Cn is 0.00. Kalau if I put it wrong, please inform me. This will be 1.0. It will be 0 plus. Of course, it's going to be 0, 0. So our answer will be 0 here. So you can try to fill in all the value, will come out to your next state table like this. After you're done with your next step table, step number 4, the last step, you need to construct the state diagram. How? Okay, we need to go slow, one by one. First of all, you're going to have your state of 0, 0. How many steps you're going to have? Of course, you're going to have 0, 0, 0, 1, 1, 0, 1, 1. See? Okay, we go slow. For our present state, if it is 0, 0, where we going to go? It's going to go to 0, 0 also. But how about our input? Our input will be 0. Okay, next. I have the present state if 0, 1. Okay, I'm here. I will go to 0, 1 also. Okay, I will go to my 0, 1. What is the input? It's going to be condition of 0. Next, I have the situation at 1, 0. 1, 0 is going to go to 1, 0 also. At what situation? 0. And lastly, 1, 1 is going to go to 1, 1 also is going to have the input of 0. Done that part. Next, we have again 0, 0 is going to move to 0, 1. What is the condition? Condition is 1. And then 0, 1, it will go to 1, 0 like this. The condition is 1. 1, 0, let's go to 1, 1. So the condition is 1. And lastly, 1, 1 is goes to 0, 0, it will be 1. So this is your state diagram. This one, of course, is much more beautiful. You already finished all that 4 steps. And lastly, if needed, if sometimes they provide you with the timing diagram, so you can answer it following the value. Of course, the CNT will be given, the clock also will be given. You need to derive the Q1, Q0. This question, I do believe it is a positive clock. So at the positive clock, going to trigger, and you're going to see one by one. You're going to have no change at all until you meet the positive clock, right? So at this specific clock, what is the value of your Q1, Q0? For at this time, Q1, Q0 is 0, 0. So now you are here at your present state. You need to generate how it's look for next. So now you're going to refer to 1, 0, 0, and then you have 1 input. So it will generate after this for your next Q1 plus, Q0 plus. This one is present, this is present, and the next will be 0, 1. Okay, if your input for your CN is 0, then it will be remain 0, 0. Okay. So in this question, in this example, you can see here, it provide you kami apa benda ni. Okay, in this example, it provide you there is something happen here. You can see supposedly you're going to go to the next step, right? Which is 0, 1. Normally last time you play that it's going to be 0, 1, it will be 0 and then it's directly to go 1, right? But yeah, in a real situation, it will be last time, if you still remember about the what is the name? This is happen what? Because you have a small gap. It is a milli or micro or nanosecond. You can't see it in your normal eyes, but there will be a gap there from a movement. If let's say from 0, 0, where it's going to go. Okay, so next is going to be like small there, it's going to be 0, 1. That's why it's moved from 0, 0 to 0, 1 if the input is 1. Similar, you're going to proceed until you meet another one, is your positive clock there. So at this stage, what is your value? It is 0, 1. Sorry, this one. It is 0, 1. So for 0, 1, so if let's say for the 0, 1 there, you're going to see here for 0, 1 is going to go directly to jump here if we have input of Cn is 1. And it will be from 0, 1 to 1, 0. So it will be from 0 thing and then 1 thing to be 1, 0. There is a small gap there, which is again, it is microsecond, it is a nanosecond, you can't to see rarely. Okay, so next is proceed to your next positive clock there. Then you can see positive clock now is 1, 0, where it's going to go. it's going to go 1 1. So it will be 1 1 later on after your clocks there. Proceed until your next clock, but our next clock now after 1 1, it is 0. So that's why it repeat back to be 1 1 until the rest, because there is no another clock there. Okay, so that is about your 4 step here. Step 1, you need to come up with your excitation equation following the schematic diagram you're given. And then next is your derivation for next state equation. After you get this both equation, then you're going to go for the generate next step table. Then you can come out with your next diagram, which is step number 4, what for this or even developing the timing diagram. Okay. So that is the things there. Next, there is another example. Okay, another example is your JK circuit analysis. For this example, we can see, we call it a method 2. You have also to get to know what is the J1, J0, but we have to input right K1, K0. And last time we only have the output of Q1, Q0, but for this we have the output of Z. That's why we need to come out for the equation also. Okay, but it's okay, we go for slowly. If you still remember about the JK things, about the tables, you need to remember and apply it later on here. But now you can see our J1 is connected to X prime Q0 directly, is already given. So about the K1 is also here, J0 is also here, and K0 is here, and the Z, of course, you can see it's directly. So this is the first step. After that, you're going to have last time you still remember for your JK transition. Then from this you can come out with your next state there. So as you still remember, if let's say you are having the 0 0, what will happen to your next state? If let's say like 0 1 for your present, if you have the JK value, it's depend on then for your next state. Now the JK transition column here, J1. For J1 is depend on the value of your X and also Q0. So from this, you can see you fill in the value, you will get J1. From here, you will get the value to put the JK value, J0, sorry, and then K0, K1. This is all getting from the first derivation equation. So after that, because you need to find out your Q0 plus Q1 plus, isn't it? So you nak dapat, you want to get this. So from here, you already get the value first for all of this. Then after that, you can come up with the next step. The next step table, if you still remember JK, you have Q. 0 0, no change. 0 1, reset. 1 0, set. 1 1, toggle. So it is depending on your present state, and you will come out to your next state following your value. Q0, you're going to see J0, K0. What is the input? 0, 1. So what is your answer? 0, 0. Sorry. What is your answer? 0. Why 0? It's going to be no change. Reset. Reset, sorry. This is reset, right? Next, if you have the value previously is 1 there, your input similar. Okay, I go for 1, 1. Over here, you have 1, 1, you're going to be toggle. So this is 1, you're going to toggle. For next state, is going to be 1. So you're going to fill in like that in terms of Q1 plus and Q0 plus. So first step, again, I repeat, we can come up with all the equation. After you get the equation, you can come up with this kind of table. If last time for D is very easy because you know D equal Q plus will be equal to D. So no need for you to think about what is the sequence value there. You refer to the value of D, you get this. Refer value of D, you get this, right? But for these things, you can see it's going to be referring to the JK value. So this J value will be depending on this. This will be here. Sama juga, it's similar also to your value here. You're supposedly having the D here. D0, D1 at this side, which is similar at the table. So D0, how you get D0? By doing this thing. Referring to the value just now, you fill in. So referring to Q1, you fill in the value. Similar basically, but this in terms of the table, so you can see it clearly. After that, you can derive your next step table by remembering the table I provide you, JKQ equal to 0, 0, no change, and etc. This is all totally for your basic JK flip-flop. After you have this kind of table, you can come out similar to what happened 0, 0, 0, 1, 1, 0, 1, 1. Where it's going to go and so on. I think it's similar because it's counter, right? 0, 0 is going to be 0, 0, 4, 0. Here will be 1. Here will be 0. So it will be similar. Only the different in terms of the JK things. But basically all the outputs supposedly will be similar. So you can see okay. In terms of timing diagram also is depend on the CN value and also clock there. Our connection now, our CNT is more like to the X now. You can see there is another X input there. So you can draw the stat diagram, which is example in the previous slide. Sama juga, it's similar. So there is 2 exercise you can try to come up with. Exercise 8.15 and 8.16. So you can try to do it to come out with your 4 step there. Okay. So in terms of this, what we can call cascaded analysis of your sequential circuit. 4 step here. Is it okay or not? Any question? So I already dragged your times. I hope that after this, for your module 9, I will record everything, but I will do extra classes, especially I want you to be understand in terms of the module. Okay. So any question?
No, doctor.
Okay, if no problem, we can dismiss. And for those who still not yet scan your QR code, you can scan so. And for the rest, thank you for your participant. For officially, we already finished our class, but I hope that we still, when the time, I will inform. Normally, for next week, I don't have class. So we can do any day. I do believe also you also will not having any class, right, for the rest of subject, because it's already study week. Next week CNY. Not yet, right? CNY is one or Tuesday start. It's okay, before your final exam, we're going to meet. We're going to discuss when we're going to meet, especially for your might be mock final exam, discussing your module 9 and etc. Okay. So I wish you all the best. I repeat again, please pray, always pray. And I hope that everything will be easier for you for your final exam. Okay. Thank you for your participation and stay safe. Good luck. Bye bye.
Thank you, doctor.
Thank you, doctor.
Thank you.
Doctor.
Thank you, doctor.
Thank
Thank
you.
you, doctor.
Thank you.
Thank you, doctor.
Thank you. Ganas lah Bibi.
Doktor, recording belum stop.
Stop lagi. I dah tekan dah tadi. Tak apa, lepas ni I ada kelas tapi I ada